This is Shakil Ahmed. In this tutorial, we will discuss extreme gradient boosting algorithm. In short, we call it XGBoost. It is basically a most powerful machine learning algorithm known for its performance and speed, and it is also called extreme as we use different additional features is compared to standard boosting algorithm. So how it works, it starts with initial prediction, usually the average of the target variables, and then calculate the residuals, which are the differences between the actual values and the predicted values, and then it build a tree on these predicted residuals, and then the goal is to find the tree that best explains the error. And the predictions are updated by adding the predictions from the new tree uh, to the previous predictions, and this process is repeated for a specified number of trees, with each tree focus on the remaining error. So how it is different, it use L1, LSO and L2 rich regularization, so it handles the high dimensional data sets well, and handles sparse data and missing data sets. It also captures the missing values in the prediction, and can be parallelized, and we can run in parallel, not only sequential. And it designed for different use of hardware resources, as and it is also used for uh, tree pruning, use a more advanced depth first approach to prune tree. So you can see the detail about XGBoost before applying into Python. This tutorial is focused on implementation in Python. So we will start with the dataset that consists of different demographic factors and clinical variables, and we are interested in predicting the 10-year chronic heart disease status of patients, and the data is taken from Kaggle, uh, no, with the name of Framingham dataset. So I will just upload the data from downloads, as I have already downloaded the data, and then we will import pandas as PD to import the data, and then read the CSV that is already uploaded, and then we can see first few observations of the CSV, and then we will split the data into test and training. We need, but before that, we need to check for missing values in the data set. You can do that as well. And let's see how we can check for missing values in the data. We can just drop out the missing values from the data, and then drop the uh, response variable from the covariates or predictor set, that is X data frame, and Y vector. We extract Y vector from the data, and then we split the data into 20% in test set and rest of the 80% in the training set. So for that, we need the train test split. We need to import from model selection sklearn, and from matrix we need accuracy score, classification report, and confusion matrix. And we also need seaborn for data visualization, and matplot library, pyplot from matplot library as PLT, and then XGBoost classifier that is used for constructing and fitting a XGBoost algorithm. So can run it. Now we will initialize the XGBoost classifier that uses the binary logistic, means we have binary classification, and then XGBoost model dot fit xtrain ytrain. So we just fit the data model and the inputs are xtrain ytrain. So we train the model. This is the details of the training process. And then we can predict the values using the XGBoost model dot predict. From this object we use, this is the object we created, and we use dot predict command and then give the input of x test, and we can see that we can also print the predicted values. And we here we have printed the accuracy and the classification report. This is the classification report, and the accuracy is 82%. This is not giving much accurate result as compared to the previous month, but the precision is much improved as compared to the previous algorithms we studied. But in a next a few couple of lectures, after next couple of few lectures, I will I would like to make a video comparing all the methods we discussed in Python and how we do the comparison. We will discuss that as well. So these are the precisions for class specific. This is the non-chronic heart disease class, and this is chronic heart disease class. And these are the average of these two, and these are the weighted averages. And you know a higher value of accuracy and precision is all considered as best. Now we can make a confusion matrix using the confusion matrix we have created using the XGBoost model, and uh, confusion matrix y test, y predict, and then PLT figure. It's the figure size. And then for heat map, we are using this is under SNS package library, and we are using the heat map, and then the input is confusion matrix. This is the name of confusion matrix, and then annotation is true, and then the color map is blue, and this is the title, this is X label, and this is the Y label, and then plot show. We can also show the variable importance. I will do this. Next code here. For now, we will see the heat map only, and it's giving a good number of, although it's small, but as compared to the previous one, it's giving some. It's detecting 12 cases of the chronic heart disease and 589 of the non-chronic heart disease. So the accuracy is basically the sum of these two divided by total number of observation. And the heat map, this heat map shows that majority of the cases are categorized as predicted as non-CHD, and they were already non-CHD, but only 12 cases out of 122 cases predicted as CHD, although and they had actually CHD. So this is the predictive performance. We are always interested in these two values, and accuracy is basically based on these two values. And then we just see the variable importance. With in tree-based algorithms, the best thing is we can see the variable importance, which variable is more important in predicting the outcome. So we use PLT figure command. This is figure size, and then XGBoost plot importance. This is also in XGBoost package. And then this is the object we have created above. and then maximum number of features. That is total we had 15 features, and then we will just plot them. You can see the importance of different features. The BMI is most important feature in predicting the chronic heart disease. After that, total cholesterol level and systolic blood pressure, glucose, diastolic blood pressure, age, and diabetes status is the least important variable in predicting CHD. So this is all about extreme gradient boosting algorithm. That is a strongest algorithm, previous algorithm that in this we basically rely on errors, and on each at each iteration we need to rectify the errors caused on the previous iteration, and try to get a more pruned and best prediction. Thank you for watching, and don't forget to subscribe and share with others. Thank you.